Okay, so here's problem 3 on the study guide. It's pretty much straightforward law of cosines problem. You can use the law of sines later to find these angles, or you can just use the law of cosines over and over. But you only have to do it twice. Once you get 2 of the 3 angles, of course, you just subtract from 180. So here's what they're given. You're given these 2 sides and an included angle. So the minute they say 2 sides and an included angle, your brain should be thinking, hey, that sounds like the law of cosines to me, because that's exactly how that equation sets up, and it works out very nicely. So that's exactly what we're going to do. We're going to set this up as the law of cosines. We're going to crunch it out. And what it's actually asking for is what is the measure of angle A and what is the measure of angle B, right? So angle A and angle B, this is our actual answers up here. But remember, you're not just going to be graded on the answers themselves. There's a whole journey in getting there. So first of all, show me that you can set up the law of cosines to find this value of C. Okay, and in this case, C squared is, remember, it starts out just like the Pythagorean theorem. So C squared is equal to 4.21 squared plus 5.71 squared minus 2 times the 2 values times the cosine of the included angle, 28.3. Okay? So this is just a bunch of number crunching. You're going to take all these, you're going to square, add together, subtract all this. On the test, I would kind of break this down into steps, make sure things are going right, and then take the square root when you're done, and make sure that you come up with the right answer. And when I crunch all of this out and take the square root, the value for C I get is 2.83. That's actually rounded a little bit, and it's kind of weird. It's actually a tenth of the angle, but that's purely coincidence. Don't get hung up about that. So this is 2.83. Now, what you want to do is say, okay, how can I go about finding these angles? And it would seem extremely tempting to use the law of sines, and there's nothing necessarily wrong with that, but I would simply caution you here. In any given triangle, at least 2 angles have to be acute. One could be 90 or one could be obtuse. And we don't really know what these angles are. But if there happens to be an obtuse angle in this triangle, it's going to be A. And because of that, we want to be a little wary of using the law of sines, because when you use the law of sines, you are only going to get acute angles. And so you're going to get an answer that may come out wrong. So what we're going to do instead is we're going to use the law of sines to calculate this B angle. Okay? So we're going to say that the sine of B, we don't know what B is, but we're going to find out. Sine of B relates to its opposite side, 4.21, in the same ratio that the sine of 28.3 relates to 2.83. Okay, so now we have a nice proportion, and we can solve proportions fairly easy. The way I'm going to do this in my calculator, I don't know if you'll be able to see this or not, but I'm simply going to take the sine of 28.3, I'm just going to start with that. I'm going to get an intermediate value of 0.47. I'm going to multiply it by this opposite denominator, times 4.21. I'm going to hit equals again, and then I'm going to divide by the 2.83. And that gives me 0.705269032, which I'm actually going to store and use later. So I'm going to store this. I'm going to hit my store button here, store it away in memory A. And then I'm going to set up this equation that the inverse sign of that number that I've got in my calculator, and that is 0.705 blah blah blah. I've got a lot of numbers in the calculator, I don't need to write them here. But the inverse sign of that is going to be my angle B. So now all I have to do is take my calculator and say, okay, give me the inverse sign, and then bring back that number I put in memory, and close off the parenthesis, and it tells me that for 44.85. I believe that's a nicely rounded number. So 44.85 degrees is the B value. And that kind of makes sense. That's about twice the angle and not quite twice the length opposite, but you kind of got the idea. Okay, so now I can take my B value to the bank, 44.85. Okay. Then I can simply take my 28.3, my 44.85, subtract those from 180, which I'm just going to do right here. Let's clear this off. 180. We're going to subtract the 28.3. We're going to subtract the 44.85. And we get 106.85, which indeed is an obtuse angle. And we're done at this point, but what I want to show you is if we had jumped in and done the law of sines for this angle that we knew just because of the size of these opposite sides, angle A was going to be the largest angle, and if any angle was even potentially going to be obtuse, going to be angle A. Turns out it really was obtuse. If we had used the law of sines, sine of A is equal, or it is in proportion to 5.71 as the sine of 28.3 is to this, we would have actually calculated an angle of 73.05 for this angle. And that is wrong in an interesting way. It happens to be the complement of the actual angle that we want. So the cautionary tale here is if you're going to use the law of sines to bust these out, make sure that you go with what you know is going to be the acute angle, right? Across from the smaller side. That way you can play it safe with the law of sines, then just do your subtraction to find that other one. Otherwise you could be going down a path that just doesn't look right. You will know you're wrong when you calculate the other angle, because what you're going to find out is if you did the law of sines this way first, you'd have come up with 73.05. And you'd have thought, great, I got that. Do my subtraction. This angle, then, when you subtract these two from 180, becomes 78.65. So you end up with a larger angle across from a smaller side. And that should tip you off right there. If you do go down that path and forget that, you should be looking at that going, wait a minute, that can't be right, something's wrong. And then that should trigger you to remember that, hey, I want to calculate the smaller angle first, make sure I get it, then use the subtraction rule to get that other angle. And this won't be that bad. There's very little calculation here. A lot of it's done right on the calculator. And as long as you're careful about how you enter things in and set things up, problem 3 is not too bad.